Welcome to lesson 6, example number 2, and it is letting us know that we have a basement wall which is 12 foot high, and then we also want to assume that a 30-pound equivalent fluid pressure, and I say that's 30 PCF, equivalent fluid pressure. What is the magnitude of the earth pressure at the base? The total earth pressure and the maximum bending in the wall. And that's exactly what we found last time. So let's go ahead and just do a free body diagram. Here's your concrete, and then it's going to be supported at the top by that floor. So there's going to be earth pushing this way. Now let's assume it's all the way up at the top. So this is earth. And so you can kind of think of it as a beam, actually. And that's the way we're going to do it. So you're going to have a reaction here. You're going to have a reaction here. You're 12 foot. And you're going to have your pressure wedge. Alright, so like we did last time, you're going to take 30 times 12 30 PCF times 12 foot equals 360 pounds per, let's go ahead and do this, pounds per linear foot per foot. Alright, and that's what, 360 PSF. I'm just going to write that. And then we know that your P equals 1/2 12 foot again times 360 equals, we already know this, but we're going to do it again, 2160. And I guess what you could do is you could use that number. We didn't have to go this far. We didn't have to go this far at all. We could have taken the active, or not the active, the pressure wedge, and we could have looked in our steelbook and found that the case number 2, simple beam load increasing uniformly to one end. That's also represented on page 113 of the study guide. And as you can see, actually I cannot see. I'm going to get my own steelbook. Alright, on page 2-296 of the steelbook, you see case number 2, simple beam load increasing uniformly to one end. And we are looking for the max moment. And you can see that this isn't the easiest equation in the world by any means. M max equals, actually you can see all that stuff, and it says 2WL over 9 square root of 3. Which, and it says over off to the side, it says also equals 0.1283 WL, which makes it a lot easier. W is this number right here, and maybe that's confusing. Let's make this W. That's a big W. And if you go in your steelbook, you can see that there's the big W and then there's the little w. The big W is your equivalent load, and the little w is your distributed load. Alright, so we go in there and let's solve. 0.1283 W is 2,160 PLF times 12 foot, and that equals 0.1283 times 2160 times 12 equals 3325.5. 3,325.5 foot-pounds. And let's check it, and then that is also what they got. So, when looking back what they asked for, they said that they want what is the magnitude of earth pressure at the base. I would say this is the magnitude of earth pressure at the base. The total earth pressure, I would say this is the total earth pressure. And then the maximum bending moment in the wall. And I would still say that this is per foot. And the maximum bending moment in the wall. And that's your maximum bending moment right here. And those are your three answers. I hope this is helpful. Please let me know if you have any questions and I'll try to get to them. Other than that, I will see you on the next video.